Okay, so we are on to our last classification of biomolecule here, so the fourth one. So we're going to talk about lipids here, and to kick things off, as we've done in the past, we're going to start with the small piece, and we're just going to work our way up. We're just going to get bigger and bigger. And so the kind of the small piece of these are fatty acids. And maybe you've heard of oils having things like free fatty acids or something like that. And that's because oils and fats are lipids and they're made from fatty acids. We'll talk about how in a little bit. So I'll have another video on triglycerides, which are like fats and oils. But to kick off, we'll just talk about what a fatty acid is. So 1, 2, 3, 4, 5, 6 of these. 1, 2, 3, 4, 5, 6. This is going to be a carboxyl group here. And so this is our line drawing of a fatty acid. So it has a long non-polar tail. It's all carbons and hydrogens, and then there's a carboxyl group on the end, and that gives us a fatty acid. So it's, this is like the fatty part, and this is like, our acid. So fatty acid. Creative as always with the names. Now there is another lazy way to write this out. I've got a CH3 here, and then I have 10 more carbons that are CH2s in the middle. So I can do that. And then I ran out of room, but COOH on the end here, so like so. But generally we just have a dash there, COOH. So there's a couple ways of representing this. Line drawing, and then a condensed formula, and then there's a trick to actually shorten the condensed formula. So if I have a bunch of CH2s, which I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, and then this is our COOH, our carboxyl group, that's it, and we got a CH3 on the end, so we just can put 10 with parentheses. This fatty acid is known as lauric acid, and it is an example of a saturated fatty acid. So this is a saturated fatty acid, which means I need to tell you what unsaturated is, right? That's where we're going to go next. And so we can have something that is going to start having double bonds in it. So if it's all single bonds, it is saturated in terms of having as many hydrogens as we can put on this molecule. And that's what we're doing. We're saturating it with hydrogen. So there's nowhere else I could put a hydrogen in here without getting rid of the carboxyl group. So it's saturated. But if I have something with a double bond in it, like say I have a CH3, I have my end, and then I have 5 CH2s, and then I have a double bond, and then I have 7 more. So these are long chains. So of course we're going to shorten it up. 7 more CH2s and then a carboxyl. So this is a fatty acid. This one is known as palmitoleic acid, and you don't have to know these names. So this is not a situation where we got names. I just like to throw them out there. Maybe you've seen it on a supplement or something like that. This is a pretty popular one. But we'd say that this is a mono unsaturated fatty acid, because it has one spot where it is unsaturated. It has one double bond. That's what we're saying here. So when you see mono unsaturated, fats or oils or anything like that, that means there's one double bond in there. So we can have saturated, we can have mono unsaturated, and we can actually have more than one double bond, and we call that polyunsaturated. So we will give an example of that in a little bit. Actually, you know what? I'll do that now. So we'll look at linolenic acid. So I've got a CH3, and then a CH2, CH double bond CH, and then I've got a CH2, and then CH double bond CH. So I'm going to have 3 double bonds in here. Man, I'm going to run out of space. CH2, it just keeps going. CH double bond CH, and then we're just going to keep going here. Now we have 7 CH2s and a COOH. And this is another popular one for supplements. Linolenic acid. And we have 1, 2, 3 double bonds in it. So we call it polyunsaturated. So this is an example of a polyunsaturated fatty acid. If it's only got 1 double bond, we can say it's monounsaturated. If it has more than 1, we call it polyunsaturated. Both of these are examples of unsaturated. We just have these 2 categories. Okay, so let's talk about the omega numbering system. Maybe you've heard of like omega-3 fatty acids, for example. I actually just drew an example of one. So we got our omega numbering system. And so omega, you got like alpha and omega, the beginning and the end, right? Alpha starts the alphabet, omega ends it. So omega is the end of the carbon chain. So when we have something like palmitoleic acid, so this is only for unsaturated fatty acids, by the way. But we got our same thing we have before. So CH2, 5, CH double bond, CH. And then we got CH2, and we've got 7 of them, and then our carboxyl group. Well, this is our omega end right here. This is our, our omega 1, or omega end, and so this 1 has to do with that bond. And so this end is like our omega, this guy is the omega 1, and so then we've got 1, and then we got 5 more, 6, we've got 5 bonds here. Well, let's write it out, It's a lot easier. So it's nice to use the shorthand when you can, but let's be safe. I mean, I know what it is, but I want to make sure it's clear to you guys. So 1, 2, 3, 1, 2, 3, 4. I need 1 more. Okay, and then I've got a CH double bond. CH, CH2, 7, COOH. So all I did is I just took this bracket and I expanded it out, okay? And so this is our 1, 2, 3, 4, 5, 6, and 7. And so what that means is this is an omega 7 fatty acid. That means the 7th bond from the end between carbons is the double bond. That's our 7th spot. So here would be 8, 9, 10. It would keep going all the way through, but that's where the double bond is. So when you see an omega 3, that would be an example of something like linolenic acid. So let me draw that one out. So this was palmitoleic, if I remember right. Yeah. So this was palmitoleic acid. And so it's an omega 7 for the reasons we just talked about. And it's a monounsaturated, right? We've only got 1 double bond, so there's only 1 omega to label. But if we look at the other unsaturated fatty acid that we drew earlier, our linolenic acid, quite a bit to draw here. So 1, 2, 3, okay. And so let's keep it going. Dash CH2, 7 of those, COOH. So the chain just keeps going through here. Alright, and so if we number this out, 1, 2, 3, so it's an omega 3. We got 4, 5, 6, so it's an omega 3, 6, 7, 8, and 9. So This is an omega 3, 6, and 9 fatty acid. And so omega 3s are really important for dietary reasons, which I'll talk about in a little bit. And so are omega 6s. And so this is why it's so popular for supplements, because it actually knocks out two needs in one. So it's an omega 3 and an omega 6. So what was this? This was linolenic. So oftentimes when you see like omega 3 supplements, this is one of the oils that you'll see in it. A lot of times people use fish oil, which, you know, tastes like fish, in case you weren't aware. There are other options, like algae-based ones, things like that, that don't have the wonderful fishy aftertaste. So there are options. Palm oil can be omega 3s. You have a palm-based one. Alright, and so our bodies cannot synthesize these omega 3 and omega 6 fatty acids. So we have to get them from our diet. So we say they are essential, which means we have to get them from our environment. So that's why so many people take supplements for these, because they can be tough to get in food as well. And what they're needed for is to help with they drive the inflammatory response in the body. So they are needed, they are necessary for this. So that's why people often take them for like as a joint supplement, because they help with the inflammatory response that helps joints out. It's generally where we get inflammation as you get older. So that's what's so special about omega 3s and 6s. So there's a certain cutoff, which if I remember right, I've worked really hard to forget biochemistry. I think it's omega 9 and above we can synthesize, but below we can't. And 3s and 6s are really important because they allow us to do some body chemistry and make things like hormones, which are important for inflammatory response. So we're going to talk about steroids, which is actually a category of lipid, at the end of this. So this will be the last video we do, but that's one category we're going to talk about. So we're going to talk about these fatty acids, and from these you can build triglycerides, you can build phospholipids, which are used for, so triglycerides are like long-term energy storage, like fats and oils. Phospholipids are for the cell membrane. It's a phospholipid bilayer, so that's a lipid. And steroids, which are the surprising one, because they don't look anything like the rest, and that's because there is some chemistry that goes on. A little bit of reactions take place and restructuring, but it's still technically considered a lipid. So generally our hormone responses are actually derived from lipids. The last point I'll make is that as these physical properties of, actually there's two more things I gotta say in this, but keep in mind that as we go through these properties of fatty acids, they're going to carry forward in other categories. So for example, as fatty acids are more saturated. This is like the trickiest thing for me to talk about in the whole class. Like if there's ever anything I get wrong in front of a class, this is it. Like I have to, like, my brain is working like overdrive not to get this backwards. I don't know what it is. Like everyone has their thing. For me, it's the melting point of, you know, fats and fatty acids and stuff. So as they get more saturated, this is going to equal a higher melting point. So what I'm saying is they stay solid. So unsaturated fatty acids are going to melt easier. They're going to be liquid at lower and lower, or at higher and higher temperatures, and no, lower temperatures. They're going to melt at lower temperatures. Yeah, there it is. So for example, and this will carry forward in the fats as well. So I'll hold off for now. We'll talk about it more with that. But think of like butter versus oil. You can get oil to be solid, but generally you have to get it colder. So you leave it out on a winter night, you can solidify, olive oil, things like that. Whereas butter or coconut oil, things like that, will be solid at room temperature. Butter's right on the line though. Get the room a little bit too warm, it starts to melt everywhere. You don't want to leave it on the kitchen counter in the summer. And coconut oil too, if you ever have a jar of it in a cabinet, pull it out in the summer, you don't have to melt it like in the microwave or anything. It's real easy. And that's because of the melting points. Alright, so the last thing I'm going to talk about in this video, so that was kind of the first thing. The next one is cis versus trans fatty acids. So this is only for unsaturated fatty acids. And that's because if it's all single bonds, there is no cis or trans isomer. Remember, it only goes with double bonds. So we talked about this in the organic section. I said it was coming back with lipids. Here we are. And so it just depends on whether you have the cis or trans isomer of your fatty acid. And so, for example, we could have something like, what do we got here? This would be a cis. Versus the trans isomer. So I'm looking in one spot and drawing in another, and it's actually working alright. And so this is the trans. So remember, it's kind of like a C. The double bond area looks like a C. If you turn it sideways, kind of looks like a C. They're on the same side. So cis means same. Trans means across. So this is, if you look at the double bond, one piece is, get off camera there. One piece is below, one piece is above. So that's your trans isomer. And so in nature, it's always going to be cis. So all unsaturated fatty acids in nature that are produced by plants are the cis variety. And so that means that these are, they're not from nature, so we can say that it's like industrial or synthetic. It can happen naturally if you leave like your fryer oil in too long or something like that. But there's some interesting stories about trans fats as well. And so these properties will carry forward as well when we talk about triglycerides in the next section. So I guess I'll bring it up now. There's always a good story. So if anyone's ever heard of Olestra chips from the 90s, potato chips, we can't digest trans fats. We have to have an enzyme to deal with this. We don't have an enzyme to deal with this because why would we? We eat plants. This is what we get. Why would we have why would we waste time making an enzyme we would never use? And so this is what you see in fats and oils. If they're unsaturated, they're going to have cis fatty acids in them. Cis unsaturated fatty acids. And that means that they are going to stay, in melting points, things like that in baking. So anyway, we'll get to that stuff more later. But with the potato chips, what you had was something you couldn't digest, but it tasted just like oil. I mean, in terms of flavor, you don't notice the difference. So they had essentially fat-full, calorie-free potato chips. I mean, they were the calories of the potatoes, and that was about it. A lot of the calories of potato chips are from the oil, from the frying oil. And so they came up with this Olay oil. I believe it was Lay's potato company that did the potato chip company that did this. And it was all trans fats. And they went, what could go wrong? Now today, some of you might know. You might have heard the story, or you're just aware of people being worried about trans fats in their diets. So if you have a bunch of something that you in your diet that you can't process, if it's fiber, that's great. That's cellulose, that just helps kind of it just keeps things moving. You know, you're not digesting it. But if it's something like an oil, there are side effects. So the first one is it's still going to cross through our intestines. It'll be absorbed like any other oil, but then we can't metabolize it, and so it starts building up in arteries. So you get plaque in your arteries from too many trans fats. The other issue is if you have a whole bunch of it. If you have just think about this. So this is very similar to the sugar-free stuff I was talking about earlier, if you can guess where I'm going. So there was a very significant side effect to these Olestra potato chips, and that was that if you ate too many, and this was on the bag, you generally don't want a list of potential side effects on your food, but this was on the bag. Potential side effects may include, it was called oily anal discharge, because that oil, you're not digesting it, it's got to go somewhere, so it just carries through, just like the sugar-free replacements. They just make their way through. Gravity takes its course. And so this is true. You can look it up. It's often listed as, if it's not the worst product of all time, it's number 2 behind the Yugo car, if you don't know what that is. Yugoslavia's pride and joy, that automobile. So, you don't see them. It was a very short-lived product, and then they found out about the heart plaque and things like that later, and so that's why they're worried about trans fats and like frying oil, and we'll talk about hydrogenation in the triglycerides section. I'll bump that back because this video is getting long, and so it can happen there as well. You could end up with trans fats. So there were some serious health issues, and then there were some serious long-term, and then there were also some very immediate concerning health issues if you had too many. So, no one ever wants to have to degrease the back of their pants, but in the 90s, there were a fair number of people who found themselves having to do that. Alright, so I'll leave it here. So hopefully you're comfortable with what a fatty acid looks like. Clearly this is different than any other type of biomolecule we talked about. It has a carboxyl group and a long carbon chain. We can have double bonds. There will not be triple bonds in here. It's either single or double bonds only. Nature's going to make all the double bonds. The cis variety, we can come in, we can make them trans, or, if it gets old and rancid, start getting trans fats in there too oftentimes. And what else was there? Oh, the melting point stuff. So, more saturated, higher melting point, stays solid. So saturated fat stays solid. So butter has more saturated fatty acids that it's made out of. That helps it stay solid. Alright. So, we'll leave it there. We're going to build on this, so we're going to talk about triglycerides next, and take it from there.